Changes. Thanks, Bryce. You set it there. So we talked yesterday about that notation SK. Okay, and when you see this written, hey guys, you with me? All right. When you see this written, there's a number here. What does that number do to your coordinates? Okay, so
you multiply it by whatever k.
Perfect. So you multiply your coordinates by whatever k happens to be, whatever number this is. So this example, and I know we did this yesterday, but says draw this segment with the endpoints 3, -1, and -1, 2. And then it says draw the image under S2. Well, that S2 means I want to take all of my coordinates and multiply by 2. So this would become A prime, which is 6, -2. And this would become B prime at -2, 4. So I'm just multiplying the coordinates by 2. When I graph those, I end up here for A prime and -2, 4 for B prime. And this is my new segment. So what were some of the observations we made about those two segments yesterday? Hunter?
When you put the two dots in a line, it goes to the origin.
Good. So if you line up the old point B with the new point B and kind of draw a line between them, and it's kind of hard because I made my dots really big, but they should line up with the origin. Like this lines up with the origin here. It goes right through the center. And then the same thing with the A points, that if you line those up on a line, it's going to go right through the center. That's because technically the way we did this size change, the origin is considered to be like the center of the size change. So collinear with origin. What other observations did we make? Okay, so the new segment is parallel to the old segment. Okay, and that's always going to be true. And then the length was doubled, right? Why was the length doubled? Because k was 2. So if k was 5, it would be 5 times as big. So length is multiplied by k. Okay, so it happened to be doubled here because k was 2. So down here I gave you the definition. This is like the mathematical definition of a size change. It sounds crazy complicated. Really all it's saying is that when you do a size change, all of your lengths are going to get multiplied by k, which is pretty much what we figured out up here. What's it called when k is bigger than 1? An expansion. Why do we call it that? Because it gets bigger. Good. What do we call it when k is between 0 and 1? That's a contraction because it's going to get smaller. What kinds of numbers am I talking about there? Yeah, decimals, fractions, things like that. And then what happens when k is exactly equal to 1?
Identity.
It's called the identity because what happens? Yeah. It's called the identity because the shape stays exactly the same. You multiply everything by 1. Okay. So that's pretty much what we covered yesterday. Did anybody start the assignment yesterday?
No.
I hope so. Okay. Was it going okay? Yeah. Maybe at least 12-1? Okay, let's look at example 1 here. It says perform a size change on trapezoid ABCD with center O and magnitude k equals 3. Okay, now there should be a point here near the O and the point didn't show up, but I'm just going to use this bullet point as my point O. Okay, so it'll give you a point and it'll say that's the center of your size change. Here's what you're going to do. You're going to measure the distance from this point O to this corner, from O to A. And I would measure in centimeters, just because it's easier that way. Okay. So I'm measuring from O to A, and I think I get like 1.7-ish centimeters. So this distance, I got 1.7. Okay. What do you think I'm going to do with that 1.7? Yeah, multiply by 3. My magnitude's 3, so I'm going to go 1.7 times 3, which I believe is going to be 5.1. Okay, guys, watch this part. In fact, you may want to just watch me do this first one and then jump in and fill in the rest. Okay, so 1.7 times 3, and I multiplied by 3 because k is 5, or because k is 3. That's why I got 5.1. I'm going to line my ruler back up with O and A. So I'm going to go back along that same line between O and A. But this time I'm going to measure out 5.1 centimeters. So really I'm like shifting point A this way. Okay, so I'm going to go to 5.1, put a dot, and that's going to be my A prime. Does that make sense? So I measured the distance between the center and the original point. I multiplied that distance by the magnitude, and then I went that same distance in that same direction. So now I would measure from point O to point B, which I think is just about 3 centimeters. I'm going to go ahead and call it 3 centimeters. Okay. So that distance from O to B is 3 centimeters. So now what?
You line it back up at point B.
Say it again?
You line your ruler back up at point B.
Okay. Okay, so I'm going to go 3 times 3 is 9. So I'm going to go 9 centimeters in that direction. Okay, remember you want to multiply by the magnitude. Always starting at the center. Always starting at O. So I'm going to line my ruler up this way, but I'm going to go 9 centimeters out to right there. And that's going to be my B prime. Okay. Let's go to C. So from O to C, just about 4 centimeters. Hope I'm not just being lazy with my measuring. But. So 4 times 3 is 12. So lining up again from O to C, I'm going to go out 12 centimeters. Just barely on there. So there's my C prime. And then from O to D, I get like 2.4, I believe. So I would say 2.4 times 3 is 7.2. And then I would go 7.2 from here. It's going to be right about there. Did I lose anybody on that? Okay. Bryce, where were we stuck?
3 times 3.
Okay, I'll go back to that. Hi.
Hey, can I put you on the agenda today for talking about blended?
Yes.
Brandon mentioned you
Yep.
spearhead that.
Yeah.
Okay,
Yep, I'll talk about it. Brandon's going to be there too, but I can
Yeah.
sort of talk about the class, so.
good.
Sure.
Thanks.
Yeah. Okay, so just to recap what I just did, because I know those last couple I kind of flew through. I measured the distance from O, the center, to each one of the corners of the trapezoid. Because that's, if I can move the 4 corners, then I really can move the whole trapezoid, right? So I measured the distance like from here to here and got 3. And then you want to take all those lengths and multiply by the magnitude, which is also 3. So I did 3 times 3 and got 9. So then I lined my ruler up on that same line, like I lined it up with O and B, and I measured out that 9 centimeters that I just figured out. Okay, so there's my 9 centimeters, and that's why I put B there. Does that make sense? Okay. Then I did the same thing with C. I measured from O to C, found that it was like 4 centimeters, and then multiplied that, got 12, and then went 12 centimeters down this way.
Wait, how did you get the 4?
The 4? I measured from O to C. So like I measured from here to here, and that's right at 4 centimeters.
Then you multiply
Okay.
that by 3.
Yep, multiply that by the 3 because that's my magnitude. Okay, does that make sense? So when I redraw it, and those should have come out closer to being in a straight line, but that's okay. When I redraw it, you should see that it's the same trapezoid, but 3 times bigger. Now, yesterday I did this example with 6th hour, and somebody said, wait a minute, that looks way more than 3 times bigger, right? Like when you look at that, you could fit way more than 3 of these trapezoids inside of here, right?
Yeah.
What is it that got 3 times bigger? The sides, the lines, okay? So this is 3 times longer than this. This is 3 times longer than that. okay? You're right that the area got more than 3 times as large. Okay, the area got significantly larger. And we're going to talk about that later this chapter, like what happens to the area when you do a size change. Good? Ready to go on another example? If I gave you a problem like that to do on your own right now, could you do it?
Yeah.
Okay. Example 2 is sort of similar. I might go a little bit faster just because I think you get it. But the difference with this one is, first of all, look at that magnitude. Magnitude is 0.5. So what's going to happen? It's going to get smaller, right? And the other thing I want you to see is they're telling you that the center is point A. Remember in the last one we had like another dot sitting out here somewhere? This time they're telling you that this point A that's on the trapezoid is your center. Okay? So this point is actually going to stay right where it's at. Point A is going to stay at point A. This is now A prime as well. And so now I'm going to measure the distance from A to B. So from A to B is 4 centimeters. Okay. So I'm going to do 4 times 0.5, which is 2. So then, staying right along that same line, I'm going to go 2 centimeters from A and put a dot, and that's going to be my new point B. Does that make sense? Now let's measure from A to C, which looks like, gosh, it's kind of hard. 6.3? I'm going to say 6.3. So 6.3 times 0.5, well, that's going to make my life hard. It's going to be like 3.15. We'll just go 3.2. I guess we could kind of try to go halfway in between, but not with the thickness of this pen. So 3.15 would be like there-ish. That's your C prime. And then from A to D is 3.6. Okay, I'm good with 3.6. So half of that would be 1.8. Okay, so 3.6 times 0.5 would be 1.8, which would be like here. That's your D prime. And then if you reconnect those, you'll get kind of that trapezoid inside a trapezoid. Okay, so there's your size change of 1/2. Okay, which means all the sides got half as big. Good with that? Okay. Example 3 gives you one that's already done. They give you 2 pictures. They said one is the size change of the other. Okay, let's see. Which one is the original here? Yeah, the dashed figure is a size change of the solid figure. So this is my original. I want to find the center and the magnitude. Any thoughts about how I could find where the center would be? Let's maybe look back at this one. And I'm going to go ahead and connect A and A prime and draw a big line. You don't have to do this. Actually, I wouldn't do this. I don't want you to mess up your example, but I want you to see something. So if I connect A and A prime, and I connect D and D prime, and do a big line. It's a little bit off, but connect C and C prime, and connect B and B prime. What do you notice about where all those lines cross? Don't they cross at that one, the center, what we used as the center before? Okay, so these points are all going to be collinear with the center, just like over here, these were collinear with the center of the graph. So knowing that, what could we do here? Preston?
It's like you.
Okay. I think you've got an idea cooking around in there somewhere, Rachel.
Connect all of the points together.
Yep.
To come to one point.
So I'm going to connect like this point with this point because those two like correspond with each other. And I'm going to draw a nice long line because I don't know where all those lines are going to cross, but I'm going to try to find it. So connect there. Okay. I'm going to connect this point with this point. Okay. go like this. So now I can kind of see where they're going to cross. But I should do the other ones just to make sure I'm accurate. Connect these two. It should be like there. And then, which other two do I have? These two. It should be like, this one's a little bit off. There. Okay. So then you can see this spot where they all connect. That's my center. Okay, any questions on that? Okay, now it also asks us to find the magnitude. Okay, so let's think about that process we went through a second ago. When it gave us the original figure and wanted us to do the size change, didn't we start by measuring the distance from the center to one of the points? So let's go ahead and do that. We're going to measure the distance from the center to this point here, and it looks like it's right about 2 centimeters.
Can we erase the lines that we made now?
What's that?
Can we erase the lines that we made now?
Sure. Yeah. Yeah, if you need to. And then normally what I would do is I would take that 2 and I would multiply by whatever k was, and that would give me the distance from the center to the new point, right? Does that make sense? That's what I would do, is I would take that distance, I would multiply it by 5 or 3 or 0.5 or whatever, and then I would go that same distance to get my new point. So let's find out what that distance is from the center to the new point. And it looks like it's 3.6, 3.7 maybe? 3.6. I'm going to go 3.6. So this whole distance is 3.6. So I know that I took 2, I multiplied it by some mystery number, and I got 3.6 as a final result. How could I figure out what k is now? Bryce?
Divide 3.6 by 3.
Yep. Divide by 2, and you get that k is equal to 1.8. Okay? So really all you have to do is take the distance to the new figure and divide by the distance to the old figure. Okay? And that's how you get your magnitude. That k is 1.8. Now, I could go do that with another pair, like just to make sure that it works. It should be the same all the way around, so it shouldn't matter. But let's just check and see how close we are. And I made some of these dots really big, so it's hard for me to tell where the actual point is. But like for example, here I'm getting 1.6. And then to the other one I'm getting about 3. Could someone do 3 divided by 1.6 for me?
1.875.
Okay, so that time I got 1.875. And with these, I do understand that there's a little bit of error just because of, like I said, if you make your dots really big or if you're just a little bit off, if your center's not right in the right spot. So anywhere in the vicinity of 1.8, I'd be fine with. Okay, does that make sense? Questions on that? Okay, one more quick thing to throw at you. And this goes back to when we talked about transformations, okay? Remember the A, B, C, D of transformations, the things that were preserved? What were they? Do you remember? A was for angle measure, yeah. All your angles stayed the same under a size change. Okay, so like this angle is still going to be equal to this angle. Whoops, you can't see that, but this angle and this angle are going to be the same. What was B? Betweenness. That means no points are going to jump out of line. C?
Collinearity.
Collinearity, good. That means the lines are all going to stay pretty much in the same position. And then what happens to distance? Because distance is not preserved, right? Your distances get, what happens to them? Multiplied by, say it again, Matt? The magnitude, yes. Yeah, they get multiplied by the magnitude. So under a size changes magnitude k, the distance between any 2 points is multiplied by that k value. Okay, so your distance gets multiplied by k. Okay, that's what you really need to know. Good with that? Yes, I hope so.